Hello, everyone. So for my program simulates how Bitcoin from a darknet market cluster may flow from different cryptocurrency exchanges. And the purpose is to analyze patterns, risk levels, and trends using simulated data sets of 220 synthetic records. The program uses the Python libraries that we learned in class, being random, pandas, and matplotlib. So for the presentation, I'll walk you through the development of the program and explain each section of code and present the findings and visualizations from the program. So beginning with my problem statement, the main question I wanted to address was for a simulation, how do simulated darknet market Bitcoin flows distribute across exchanges, and what patterns or risks can be identified over time. To answer this question, I built a synthetic data set, which you can see it here. I built a synthetic data set inside the program and performed uh, descriptive statistics, data cleaning, time series analysis, and visualization. So for the data set itself, it contains 220 rows. Each represents one simulated transfer event. And each event includes the exchange name, the Bitcoin received, the number of transfers, the risk score, and a sequential time. And for this case, the time, there's no actual timestamp, so this just refers to the order of the recorded transfers in this supposed system. Okay, so moving to the code itself, the first function dealing with the imports. So first, I imported pandas, and then matplotlib, and then random. Like I said before, this was for data handling, was for pandas. Matplotlib was for plotting the actual graphs, and then the random library was for data generation. And so for the date, moving on to the data set generation function here, move this up a little bit. Uh, the function creates the full data set. So these exchanges are real exchanges used for the simulation. And the list of exchanges where the Bitcoin in this scenario was sent to. So for the inside the for in loop, the exchange is randomly selected. The Bitcoin received is a random float. The transfers and risk score are integers with realistic ranges. And for each record that's opened, um, for each record appended in the dataset list, it's called here. Sorry, I'm just getting lost in my notes here. So moving on to the cleaning function. The data set technically doesn't need this since I actually included the synthetic computations inside, but I just included it anyways because it's part of the assignment. But the function performs the required data cleaning steps. So it checks for missing values, and it removes duplicates and converts data types. You can see here, duplicates removed. Moving on to the statistical stats function. The function calculates the maximum Bitcoin value, the minimum Bitcoin value. Oops, sorry. We are at the stats. Maximum Bitcoin value, the minimum Bitcoin value, the average Bitcoin value from the simulation, the time index. So it captures the max time or the max time incurred. So the values, so this is like the greatest, like the number one, the first and last values, or it should be. For analyzing the data, here I calculated the difference between consecutive Bitcoin values using the difference command. And so I identified the largest increase and the largest decrease. And from there, I also captured when these instances occurred. So for the max values here, they're captured. So in the actual main function itself, we can start with the define main function here. So this just actually runs the workflow, of course, moving down to generating the data set. This is just converts the list of dictionaries into a pandas data frame. And for the added time series variable, this was done since the data is simulated, like I said before, and there's no actual like real timestamp. So it just creates a logical timeline that you can analyze if you run the program. Next is the cleaning data. Cleaning data piece, and this just captures missing values and duplicates, and they're removed from the actual final table, and all the data types are validated. So moving on to the actual computation of the statistics, we have the maximum Bitcoin, minimum Bitcoin, and then the average Bitcoin calculations reported here. Also, the times are captured as well, so they have that go in tandem with those values. For the time series change analysis, I calculate the difference between the periods to identify the largest increases and decreases in the values. So you can see it here, largest increase, largest decrease. Also, the times are captured as well. And so lastly, for the visualizations themselves, I have the line plot, the bar chart, and the pie chart, and just pulling those up here. First, we have the pie chart, and it shows that Coinbase from the simulation was the exchange with the greatest exposure to Bitcoin that were sourced from darknet marketplaces. And Binance in this scenario had the least amount of exposure. And so we can see the same thing here, just done through a bar chart, Coinbase with the most, and then Binance showing it the least. And then finally, we have the scatter plot, which does a better job of just showing volatility in the exchange itself over time and just the changes of values of Bitcoin transferred and received from the simulation. But that is all I had for my program presentation, and thank you for your time.